So where shall I start? How about, you get what? Oh yeah, go for it. So I got this shape right here. Does anybody have anything that looks like this one? You got one? Okay, yeah, that looks all like mine. So what can we say about it? It's got a right triangle on one face and a matching one on the other side, right? Anything else? Make a great doorstop. And what else? I think those right triangles are parallel to each other, parallel planes. Okay. And then, yeah, okay. So I got that one. There's another one. Anybody have one that looks like this? Okay. Anything you want to say about this one? Pretty similar. Well, it's kind of similar but different to the other one. The other one has more surface area, maybe? Yeah, it might. We'll check that. Okay. So this would also make a good doorstop. True? Yeah, okay. All right. Ooh, this one's kind of cute. Anybody have anything that looks like this? Could possibly make a doorstop. Might be a little too steep. Doorstops are a little more shallow. But is it kind of sort of similar to the other two? It's got a pair of parallel triangular faces, right? Okay. I got, ooh, here's another one. It's got, ooh, well, let's see, 1, 2, 3, 4 triangles. Oh, wait, we've seen a 4 triangular three-dimensional shape before. What's it called? Tetrahedron. This is a tetrahedron. Tetra is another thing for 4. This has 4 faces. They're triangles. Is it different than these other 3 shapes I had before? It comes to a sharp point, right? The other ones definitely didn't do that. They had a sharp edge, maybe, but not a sharp point. They've gotten a little dull with age, but all right. So that one seems different to me than the other 3. Agreed? All right. Tetrahedron. Anybody want to give this another name? A pyramid. Yeah. Usually when we think of pyramids, we think of like the Egyptian pyramids, but it turns out that's a pyramid with a square base. This is a pyramid with a triangular base. Okay. Are either of my first 3 figures, could we call those pyramids? Pyramids, what's the difference between this shape and a pyramid, would you say, like a fundamental difference? Yeah, the pyramid comes to a point. Yeah, okay. Does anybody have a different kind of pyramid? Ooh. Oh yeah, you got a square base pyramid. Cool. Let me just show this to the camera. So this was my triangular base pyramid, my square base pyramid. All right, give this back. You had a different one, Tiffany? Yeah. Ooh, that's wicked cool. So this one has a square base, but in Nikki's, the point that the tip was straight above the base. This one, the tip is straight above 2 of the sides. Anybody else grab one of these funky? Oh, it's slippery. I think it's because I'm trying to keep my fingers out of the way of the camera. Nobody else got, oh, I got one of these. Ooh, they look identical. Well, that's kind of cool. All right. Okay? Yeah. All right. Let's see. How about this one? Would this be a pyramid? Definitely not. It's close to the other shapes I grabbed in the beginning. So far I have 2 kinds of shapes. I have pyramids and other kinds of shapes. How about this thing? Looks like a cube, yeah. And is that more similar to a pyramid? The other shapes or neither? It has more sides than the other shapes, yeah. Yeah. All right, we're back. Let's see. I did give them both to you, and I might even give you a third one soon, because you're so good today. All right, how about this sucker right here?
Kind of like this one.
Yeah, it's kind of more similar to those. So I'm just going to come back to this one for a second. Has anyone ever seen something like this but made of glass? If so, do you remember what it was called when it was made of glass?
Prism.
A prism. Yeah. So it turns out that is actually a technical geometric term. And all of that first group of shapes I got, including the cube, all these guys here, these are all prisms. So now look through your shapes again and see if you can grab anything based on the cube and those triangular type prisms. Find anything else that might be classified as a prism. So I got a bunch of prisms. And so then I'm going to show a couple more shapes, and we need to decide together whether they're prisms or not. So let's see. How about these two?
Oh, I don't know.
Okay.
Here's the plus 4.
All right.
3.
So I've got this shape right here. Could this be classified as a prism? Is it really much different than the cube? Okay, how about this shape right here? So is it much different than this shape right here? Yeah, this one has a triangular parallel faces that are triangles. This one has parallel faces that are hexagons. This right here, you could say, has parallel faces that are squares, and it happens to have some side faces that are squares too. And this one right here, depending on how you orient it, I could say this is my face, and then it has parallel, perpendicular sides to the other face. Or maybe I could say this is the face, and it has perpendicular sides heading down to it. So there's all different kinds of prisms. Typically, when we're talking about a prism, what we mean is a pair of parallel faces that are congruent to each other, and then sides that are flat and perpendicular to those faces. That makes sense? Parallel faces, we can call those the top and the bottom, and then the side faces, they're perpendicular to those parallel faces coming down. And we have a whole bunch of figures that fit that pattern. And those are all called prisms. So we have one big class of figures called prisms. We have another big class of figures called pyramids. So I'm going to show a couple more pieces, and we're going to decide if it's pyramid, prism, or neither. This one does actually have a special name. Anybody remember? This is a cylinder. Is a cylinder more like a prism or a pyramid? Yeah, it's got a pair of parallel faces, and then the sides come straight down. Now, it's just got one big curved side instead of flat side, so it is different in that way, but it's similar in other ways, right? Because it's got the parallel faces, top and bottom, and perpendicular side to that. All right, let's see. There's another shape. We got this one right here. Okay, this is more like a pyramid, right? Because it comes to a point, but it has a special name. It's a cone, yeah. But it's similar to the pyramids because it has some kind of flat geometric base, and then it has side comes to a point right on top of that. So I'm going to throw it into the pyramid category. Okay? Even though it doesn't have a polygon for base, it's pretty darn close to a pyramid. And we'll see later that it has some other properties that are pretty similar. All right. So did anyone get a shape that is neither prism nor pyramid? I see 1, 2. Okay, let me borrow yours here. We got the same one back there. We got this sucker right here, which is called a sphere. Yeah, sometimes we call them a ball, a ball or sphere. And neither prism nor pyramid, it's a whole other class of object. And then I hid some toys over here that I'll share in a minute. If I back into the camera here. So these are my magic dice, and these are special figures that are not prisms or pyramids, well, except for that one and this one. I got this one. That one's kind of an oddball too. And this one. Okay, so I'm going to pass. I got 2 sets of these. So take a good look at them for a second. Make a couple of observations about them, and pass them on to a neighbor. Set started in front, set started in back. Take them out of the bag, take a look at them, make a couple of observations about them. So we're jumping into a new class of shapes. So kind of like in 2 dimensions, we have polygons. In 3 dimensions, oops, I got to shift the screen. Sorry, future audience. On screen. Come on. Uh-oh, broke my screen. There we go. In 3 dimensions, we have what are called polyhedra. And hedra refers to having a flat face. So the cylinder doesn't really fall in the polyhedra category because it has a curved face. The cone is similar. It doesn't really fall in the polyhedra category because it has a curved face again. But we can still fit it into, the cone still fits into the pyramid category, and the cylinder still fits into the prism category for some other reasons. But they don't fit into the polyhedra category. So then there's all kinds of crazy polyhedra out there that are neither pyramids nor prisms. They're just other shapes, and sometimes we can name them. People have come up with naming schemes for these. There's a special group that are kind of shown in the middle here that are just drawn with lines, they're transparent. So I'm going to see if I can take a look at that group. This is a cute picture right here, maybe. Share the image, please. Blur you up, perhaps. So we already saw the tetrahedron. That is a kind of pyramid. The octahedron's a new one. We haven't seen that one yet. We've got the cube. That's what, a pyramid or a prism? Prism. Yeah. The icosahedron. The dodecahedron. We've seen dodec before, haven't I? Brought that up in a previous class. Anybody remember what dodec means? 12, yeah, this has 12 faces. We looked at a dodecagon one day in class when we were playing with a circle. So it had 12 sides or 12 edges. The icosahedron has 20. And those dice I showed around the classroom had each of these, plus it had a 10-sided one that's not shown here. And so these are called polyhedra. So we're going to play around a little bit with polyhedra. There's a special group of polyhedra called the platonic solids. That's a nice picture right there. So these are the platonic solids right here. So they are thought to be the 5 most perfect polyhedra in existence. Okay. They were discovered many, many, many years ago. Notice the name of them, platonic. So Plato is attributed to having said these were the most perfect geometric solids. You got it wrong, Kristen?
Yeah.
Okay. Hope everything's okay? Relatively?
I think my water broke, so.
Oh, shit. Okay. Do you need a ride?
No, my husband's on his way. He's
Okay.
he's washing up and telling my dad. So
Okay.
we're just going to go check.
Just going to go sit down and chill out somewhere in the meantime?
Yeah, I was going to sit outside it just in case.
Okay.
I don't want to curse everyone out. It does happen.
Okay.
I'm
my
going to sit out in
gosh.
the hallway.
You just holler if you need anything from us, okay?
Have fun doing math.
Yes, we will have.
Bye.
Good luck.
Thank you. We're so easy.
Yeah. We wish no baby yet. Okay, brief intermission there. The excitement of class. So the tetrahedron, notice they gave the cube a new name, the hexahedron. Why do you think they're calling it the hexahedron?
There's 6 faces.
Yeah, the 6 faces. Hex is the 6. Yeah, 6 faces. The octahedron, it has 8 faces. The dodecahedron and the icosahedron. So let's see. What can you tell me about the hexahedron? Anybody have one in front of them? There. Here. There's the hexahedron. Okay, hexahedron's back here. You got one right there. Goes around. All right. So I'm running out of hexahedrons. Oh, here's a little baby one.
Oh, I have 2.
Oh, you had 2 of them. Oh, look at that. You did. All right. So what can you tell me about the hexahedron? Got 6 faces. Okay, so we got that. They're equal. What's another word for equal in geometry? Congruent. Yes. Okay, so we're talking about the hexahedron. Hexahedron. It has 6 congruent faces. And remember, we're going to try to not use the word side, because in 2 dimensions, side would mean an edge. In 3 dimensions, maybe it means a face. So we're going to try to avoid using that. It's going to always pop up. I'll say it once in a while, so will you. But we'll try to say faces when we mean a face and edges when we mean an edge. How about edges? Can you tell me anything about the edges on that thing?
Are they also... Would this be like regular?
Ooh, that's an awesome observation. All right, so we have question mark. Is this a regular 3-dimensional figure? So in 2 dimensions, something was regular if it had all the same angles and all the same edges, then it was regular. In 3 dimensions, we have another thing to throw on there. It would have to have the same faces too. So checking out that, well, it's got 6 congruent faces. It seems to have how many congruent edges? 12? Yeah, 12 congruent edges. Congruent edges. Okay. And then there's vertices. Let's just count. The vertices can't really be congruent because they're just a point. But how many vertices does it have, just for fun? Almost 8. It has 8 vertices.
Oh.
Now, angles, they come in a couple of different ways. Angles can appear where 2 edges meet, and angles can occur where 2 faces meet. So consider where all of the faces meet. Don't they meet in the same kind of angle? Okay. So faces meet at same angle. How about the edges? Now, this happens to be 90 degrees. Do the edges all meet in a similar fashion? This edge and that edge, this edge and that edge, this edge and that edge. What can you tell me about any place where a pair of edges meet?
Always a 90 degree.
It's always a 90-degree angle. Yeah, the edges always meet. So I think this constitutes the idea of 3-dimensional regularness. So that was awesome, Taylor. Good observation. So the edges also meet at the same angle. Edges meet at the same angle. And that's exactly what we need to call something regular. in 3 dimensions. So yeah, the hexahedron is a regular polyhedron. Okay. So let's take a look at another one. Let's jump back a level and look at the tetrahedron. And there's some websites that have these cool rotating pictures of them in case you don't have your own 3D version with you. Let's see if I just search for it, I'll find it. Tetrahedron. Wikipedia usually has some cute. Click here for the rotating model. Woo! Oh yeah, there we go. Look at that sucker go. All right, it's moving kind of fast. Wish I could slow it down. It does seem to have congruent faces, right? All the edges seem to be the same length. And can I pause you? I got to go back and hit the other version. Stop. They need to have a pause button there. Okay. And does it seem like, so a few of you have those in front of you. Sorry, I stole some. I don't have many of these, but you check that out. Does it seem that the angles of the faces all over the place are the same? And where the edges come in, they're the same too. Yeah, if you just pass that around, let everyone else check it out. I think you can use it. Tiffany, you have one you can chill around back there. All right. So yeah, wouldn't you agree that this seems to fit the idea of regular for a polyhedra? All right, so screenshot this sucker here. Oh, do up the screen. I just screenshot the whole thing. Oh, there it goes. Delay. Yeah, so this is another regular polyhedra. Proving that all the angles are the same, that's another matter. We're not going to get into that, or polyhedron singular. And just some notes about this. How many faces does it have? 4 faces. How many edges does it have? 6 edges. And how many vertices does it have? 4 vertices. All right, let's try another one. How about the octahedron? Sure, why not? We do have an octahedron floating about here. You could take a look and then pass it along. I'm going to go grab a screenshot. So this is the octahedron. And so the question is, does it appear to be regular? And here comes the rotating model. Woo! So if you look at any one vertex, does it seem any pointier than a nearby vertex? Or does it seem about the same all around? Like there's no like up orientation. It's just similar all over, or congruent all over. Yeah, if you play with it, you'll find that when I'm looking at it, that one seemed like the pointy one, but now that one seems like the pointy one. No, maybe it's that one's the pointier one, but they're all the pointier ones. They're all identical if it was built right. All right, so the octahedron is yet another regular polygon, or polyhedron. Polyhedron. And let's see, it has 8 faces, right? Edges. What do you think? 12? Yeah, I think it's got 12 edges. And vertices. 6. Hey, that looks familiar. Did we already see something like that? 8 edges, 8 faces, 12 edges, 6 vertices. Oh, it's backwards of the hexahedron. Hexahedron is 6, 12, 8. The octahedron is 8, 12, 6. Interesting. Might that mean something? I don't know. Let's see. All right, so I'm going to hold off on doing the other two. I'm going to let you guys do those later, and we'll talk about it some more in the next class. There are not as many regular polyhedron as there are regular polygons. So we have a 4-faced regular polyhedron. We found a 6-faced regular polyhedron. What happened to 5? Is there a polyhedron with 5 faces that's regular? Then next one we saw was the octahedron. That has 8 faces. Is there one with 7? Okay. So these are some mysterious questions that puzzled people for a long time that were solved a while back. And we're going to hold that mystery till next class. Let's see. I think I'm about done classifying these things. And I'm going to give you a homework assignment. Your homework assignment is to do a little bit of research on polyhedron. And so, for example, I just went to Google and I searched for polyhedron. I hit the image search and all kinds of stuff pops up. So what I'd like you to do is find an interesting polyhedron and report back on it on Monday. Yeah, it could be a picture. Maybe you might get lucky and somewhere in your existence you might come across one like, oh my gosh, look at that. There's been a polyhedron sitting in my living room all this time.
Does it have to be a regular polyhedron?
No, it does not have to be regular. So the specific assignment in Canvas, I want to make sure we get this right, is to find a cool polyhedron. You get to define what cool means. And you just need to show up with some representation of it. Maybe it's a 3-dimensional version of it. Maybe it's a picture of it. Okay. There's some other ways we can represent polyhedron that we're going to see in a few minutes. And then bring it with you to class. And one question I have for you is, can you build it? Or can we build it? So we're going to build some stuff on Monday. With building stuff in mind, I just want to, I've got a few things here. Change the camera for a second. Another assignment for Monday, and I forgot to post this in Canvas. Hopefully you all will remember. So, is could you bring stuff to build with? So for example, I brought toothpicks. I brought straws and string and what are these things called? Fuzzy sticks. I have glue guns and soldering irons. And so I'm going to bring a ton of stuff to build with. So if you can think of anything you might have in your supply of art stuff that you could bring to help build stuff. I'll have a ton of stuff if you don't have anything, but think of stuff you could bring that you could build with. If you remember, a couple weeks ago, we played around with some 3-dimensional stuff and we had that little sticky tag tape glue stuff. So I'll have some more of that. So I'm just going to bring lots of stuff that we can use to build things. So we're going to take a look at the polyhedron people bring in, and we're going to try and build something. Maybe it's your polyhedron, maybe it's somebody else's, and we're going to get started on a little art project for next week with some 3-dimensional geometry. All right, so we are going to start building some 3-dimensional geometry things right now. So I need to back up a couple of assignments here. We're going to take a look at activity 8. Which jumps us into taking a look at the surface area. One thing that came up earlier when we were comparing a couple of these, that this flatter one might have more surface area than that one. So we're going to just play around with surface area here. To do this activity, you need the printouts, and I have some with me, of solid A and D and solid B and C. So we're going to cut these out and tape them together, and then we're going to classify them and then measure them. So I have tape up here, I have scissors up here, I'm going to hand out Polyhedra. Oh shit, I forgot to change the view of the camera. Sorry, future audience, Emily. There we go. So, activity 8. I need these 2 printouts. listed on the activities. So here's one for you. So the tags, the gray tags on there, are there to help you get it to stick together better. Different one.
Do we need these?
I can combine collectors. I guess that's A and D. Here comes B and C. See for you and you. Okay. All right, so this is where the video gets boring, so feel free to zip ahead. While we cut stuff out and collect blocks. Some days when I'm cutting these out, where I say, forget about those tags. So when we have shapes like this on paper, these are called nets for polyhedron. And so try to guess what your net is going to build before you tape it together. I'm still going to have you be keeper of the magic pyramids.
Okay.
All right, so Emily, in the future, your job, should you choose to accept it, is to cut these things out, tape them together, classify them, and then attempt to measure them and discover their surface area. Next week, we will find their volume. Over and out.